I'm Mary Clair Thompson. Thanks to Joe and to Matt Housley for inviting me to give this talk. Thank you all for showing up. I am a data engineer in the Office of Information Technology at Duke. I've spent all of my career in industry working with data in some way. At my previous position, I was a software engineer and data scientist at a local ad tech startup. And before that, I was a data scientist at Overstock.com. So when Matt asked me to give this talk, obviously I knew I was going to talk about, we'll introduce Prefect, talk a lot about the backend, the UI, the API. But I also thought it would be really interesting to spend some time just discussing the decisions that led us to land on Prefect as our workflow management tool. And so I wanted to just give you that arc. We'll start off nice and easy, nothing too technical to get us going here. To do that, I need to give you a bit of background about my team. We are a long-established team. We're the data analytics team within the Office of Information Technology. But in the last few years, we've had an influx of new members. Myself, I've been at Duke for just over a year. My boss, John, who's on the call, has been at Duke, I think, roughly 2 years. So in addition to us two new members, we have several other really new members to the team. And with all of this sort of not really upheaval, but just like addition to the team and older folks leaving, we've had a lot of changing team dynamics and as well as priorities. And in particular, with the pandemic, we've seen a real shift, not an entire shift, but certainly a market shift from a real analytics focus to lots and lots of data engineering. So the team already had a legacy workflow management system in place, which, when I say legacy, I mean legacy. It has given my boss, John, many headaches. And there was a point in which it became really apparent that it was time to shop for something new. And so we established this goal to find a modern workflow management tool that would fit our team's needs and be able to evolve and grow with us. One thing that I should say about our team is that we do have a very wide range of skills. We have folks who are really, I would call them Tableau experts, but who perhaps are not as comfortable writing Python. All the way to folks who have written production code for ad tech bidders. So we have just a lot of skills and a lot of people who approach things differently. And so one thing that we wanted to do was find a tool that would be pretty user-friendly. So as we were thinking about requirements, I think one of the first things that became really clear to us is that we wanted jobs to be code. The legacy workflow tool that we were using, or that is still in place, writes jobs as, well, you build jobs using a UI, and I don't really understand it because I refused to learn it. So the thing that I do know is that there's XML controlling the jobs in the background. It's really hard to figure out how to, what changes to the XML mean in terms of changes to the jobs. And so we wanted some kind of tool that would be something that was easy to manage and a tool where we could track our job changes with Git. In addition, being easy to learn was pretty important. As I mentioned, we have a lot of varied skills on our team, and so we didn't want anything that was too daunting, preferably in a common language. And as you can probably guess, we are a Python shop, so that meant jobs should be Python. In addition, this was kind of my pet project, and I realized at some point that regardless of where we went with this, I would probably be managing the system. And so I wanted something that would be fairly straightforward to manage. A reminder, I'm a data engineer. There's a long list of things that I am not, and I would put systems engineer or architect pretty close to the top of that list. So I wanted something that was pretty seamless in terms of backend and management. And then obviously we wanted a system that could handle modern data engineering needs. We're constantly moving data among a variety of resources, both local resources and cloud resources. And then I gave bonus points for projects under active development, and I'll say more about that in a few minutes. We are, so when we were looking at contenders, there were several that we essentially threw out almost immediately. We are using Azure as our cloud supplier, our cloud vendor. And so the Azure folks did tell us, well, you should look at Azure Logic Apps. And we did, and we realized very quickly that you manage your jobs through a UI, you drag and drop things. It gave us immediate heartburn, and so we dumped Azure Logic Apps pretty fast. It was crossed off the list almost immediately. I did take a few minutes to look at NiFi, but we had a similar problem. I did not want to deal with the UI with creating jobs. We were really confident that code was the way to go. And so with that in mind, I really was pretty confident that we would end up choosing Airflow. Obviously, it is a well-established contender, so, and I have used it before. So I was pretty confident that we were going to end up landing on Airflow, but I did want to spend some time doing some research to see if there were any other products out there that could meet our needs. And as I was researching, I ran across Prefect, and I thought it was pretty intriguing. And so with that in mind, I installed it and started messing with it. And it became clear pretty quickly that there were a number of things that we liked about Airflow that were also true of Prefect. So they're both open source. Prefect is very newly open source. You write jobs in Python, which again, checks off that very important requirement to us. They both have a really nice web UI. And I really like that you think of jobs as being directed acyclic graphs in both of these cases. And then, of course, Airflow had some very obvious pros. First of all, that I have used it before, so that was pretty nice. But also, it's sort of like the well-established industry standard solution. And so again, even in the first stages of evaluating Prefect, I was still pretty confident, you know, Airflow is great. We'll probably end up using it. I'll probably find something we really don't like about Prefect, and that makes it clear that we need to just stick with what is known. So again, I installed Prefect and started working with it, and I found that there were a lot of things that I really liked about it. One very superficial thing, but I'll mention it anyway, is that it was very shiny, brand new, installed the UI, and I was like, oh, this is really beautiful. And as I have been upgrading, as the versions have, as they've been adding features, that is, the UI has just gotten nicer and nicer. I think it's really clean and pretty easy to navigate. And then, of course, I really liked that the authors built it specifically with modern data engineering needs in mind. There is a nice article that you can look for online, giving a lot of information about that. It's just called, I think if you just Google why Prefect, you'll find it. I really liked that it is actively developed. And part of the reason for that, well, there are a lot of reasons for that, but one of the big reasons, again, is that I'm essentially the one who's installing, managing all of our Prefect setup. And there have been a number of occasions where I've just run into something that I couldn't figure out. And on every one of those occasions, I hopped onto the Prefect Slack channel and got either an entire answer or at least something that helped me figure out the problem within 20 minutes. And the folks have been really nice and really helpful. So that is something that is a huge pro to me. I also really liked that Prefect has a task library that allows for a number of integrations with resources that we are using or will potentially use at some point in the future. So as we grow, we may touch Docker, or we may switch to Azure or to AWS, that is, instead of Azure. And Prefect supplies a number of an entire task library with connectors for Azure, AWS, Google Cloud, Docker, a number of resources that are not even coming to the top of my head. So I really liked that about it. I also liked that you can alter your installation pretty easily. You just modify your Docker files. I haven't had to do that yet, although there was a point that I thought we might need to when I was having an issue with one of the virtual machines that our installation was running on. And then probably the most important is the API. I really like the API. It's very simple, very powerful. There's both a functional and imperative API. You can mix and match code from both, and obviously provides loads of really nice conveniences for scheduling, retries, logging, etc. And honestly, I thought that the way that you construct flows, so in Prefect idioms, a flow is what we think of as a job. I thought that that was much more straightforward than the Airflow DAG definitions were. And so taken all together, we ended up deciding to stick with Prefect, and it's been really great, and I'm really enjoying using it. Probably 6 to 9 months into really like hardcore going into it. So the next thing that I want to do is talk about the backend and the UI. A bit briefly, I'll spend more time on the API. The backend architecture for Prefect is Docker. It runs out of a number of Docker containers. And there is the Prefect engine, which keeps your server up and running. There's an agent, which is responsible for querying for jobs, kicking them off, and doing some management. Prefect exposes GraphQL to you to query your API if you'd like. And it also has Postgres running in the background to keep track of your job history. There are a number of ways to deploy. We have Prefect running locally on just a single virtual machine, and it has been totally seamless. It is definitely fitting our needs right now, although as we grow, as we add more jobs, that may change, but we do have many other options for deployment. If you have a Dask cluster, you can deploy it there. In the cloud, there is support for AWS Fargate. And one thing I'm very excited about is that you can deploy it via Azure ML if you'd like. Again, we're an Azure shop, so this could potentially be very useful. And then there is a managed Prefect service. So this is really cool if you are a single developer and just want to mess with Prefect and don't want to have to deal with installing it. However, if you want to use this for a team, you have to pay for it. And then if you'd like to run it on Kubernetes, you can. It'll deploy a Dask cluster in Kubernetes, and you can go from there. All right, so that's a very brief introduction to the backend. Let's take a look at the user interface. I have our production user interface here. So this is sort of like the front page, what you get to when you navigate to the server, the top bar here lists all of the runs that have happened in the last, what looks like roughly day. You can see the relative lengths of times that they took. If you'd like, you can hover over a particular job to see information about it. So I can see that this was the red cap to CDR update job. It succeeded. I can see that it took a little under 6 minutes to run. There's a summary box for just summary information about the runs, information about failed flows, runs that are upcoming, notifications. If you have any runs in progress, there will be information about that in this box. And then information about agents that are up and running. So that is the overview tab. If you click into the flows tab, you can see all of the jobs that are running or that are registered with Prefect. And so we'll just look at this top one to go through what's here. So there's the name of the job. You can toggle the schedule with this button if you just want to turn it off from this page. You can see that it's in the data engineering project. I really like the versioning information. That's really helpful. So this is the second version of this project, and I can see when it was created. And then I can see summary information for the runs of this particular flow. So then I'm going to click into a particular flow, and I'll get a lot more information about it. You can see that the flows overview page is kind of similar to the front page for the for Prefect itself. I have summary information about the flow, activity, information about the schedule for this flow. In addition, I can click through to look at a particular version if I'd like. I can kick off a run by hitting this button, which I'm not going to do now, because this is the prod installation. I can find out more information about the particular job by looking at the tasks. Prefect does not expose the code for the tasks. I believe the Airflow does do that, but I don't mind it at all because, I mean, I'm developing them, so all I have to do is go to PyCharm and see what the code is, or Git. I can see information about specific runs of this job, and I can look at a directed acyclic graph giving information about the dependencies between tasks for this job. So you can see that for this particular job, we have a task that gets credentials. The credentials get passed to a task that gets data, which passes data to write data revenue, which then passes data to a task that sends an email. I can click into versions here if I want. I can go into the run if I'd like, but I think what I want to do is go back to a specific version or a specific run of this job. So you can see that the very last run that we had actually failed. And so one thing that's really nice about Prefect is that you can find out very quickly exactly where and why it failed. So I see that the first 3 tasks ran totally fine, but this get data task failed. So I can just hop in here, take a look at the logs and see that, well, it looks like the server on the other side had some kind of hiccup. All right. So that's a quick overview of the UI. With that, I want to go back and look at the API. So again, this was one of the big selling points for me. I really like the API. So let me introduce sort of the paradigms, the speak the language of Prefect. The most basic unit in Prefect is a task. It's what you use to construct a job. Think of it as the sort of the definitions in your Python code. In addition to tasks, there are flows. Think of stacking tasks together to get a flow. The flow is your job definition, and it really is used to define dependencies among your various tasks. Prefect also has a concept of states. The state is just the current status of a task run or a flow run. So things like pending, running, canceled, etc. And then we have state handlers as well. Those are used to respond to a change in state of a task run or flow run. Prefect also has some nice convenience classes for logging. It's very easy to set up schedules through the API, and you can add parameters really very easily. I just figured out how to do it this morning and now have a flow up and running with parameters. There are many, many more things that I could talk about in terms of really nice functionality that the API offers you. We don't have time. And so I'm basically going to scratch the surface. But this is an intro, so that's fine. One thing that I do want to say about flows themselves, a flow is, again, just, it's really just a way to define dependencies among the tasks in your job. And there are two ways to do that. You can either define a dependency implicitly by passing in the result of one task as a parameter for the next task. So Prefect then infers, well, task one should run first. Of course, there are times where that doesn't make sense. But if you want task one to run before task two, or task one to complete successfully before task two, there is a very easy way to do that. You just set it explicitly as an upstream task. And I'll show an example of that when we look at some code. All right, so I mentioned that one of the things that I liked about Prefect was how simple it is to create your first job. I'm going to demonstrate this in a sort of a very naive way, but honestly, if you were creating your first Prefect flow, this is probably how I would go about it. So write your Python script. Do whatever you want to do. And then decorate your definitions with this @task decorator. So that just indicates to Prefect what the actual tasks are. And then stack your tasks together to get your flow definition. And that's pretty much all you have to do. One thing to note is that if you have the right setup, then tasks can run concurrently unless you've indicated otherwise in your flow definition. So a toy example, very silly script. We have a definition that when you run it, just generates a random number between 0 and 1. And if you run the script, then you'll generate a random number. So if I wanted to convert this to a flow, well, I would need, obviously, to import some Prefect classes. I would take my same definition, and I would just give it this decorator. And then I would write my flow definition. Very simple flow definition, and we'll look at a more interesting one in a few moments. So the interesting thing about the script on the right-hand side of the screen now is that if I run the script, I'm not actually going to generate a random number. What happens is that I have just defined a flow. I have defined the dependencies between tasks. If I wanted to go one step farther and register the flow and have it appear in the UI, then I can add one more important statement, flow.register. And when I run this script, not only will I have defined dependencies among the tasks, but then I will also have told Prefect that we have a new flow and Prefect should pick up all the information it needs and expose it in the user interface. So I wanted to give you an example of a slightly more interesting flow where we can look at some code. To do that, I'm going to switch to my dev installation of Prefect. So give me just 1 minute to do that. And we'll hope that the demo gods shine down on us here. My dev server has been slow to respond today, so apologies if this takes me a little longer than it's Friday, the server's tired. I don't have any memes or anything to show you while I wait for it to respond to me. I apologize. I definitely should have planned that. There we go. All right. Okay, cool. We are up and running again. So let me do another share. All right, so I wanted to demo a specific flow where we could look at the flow itself and look at some code. So I'm going to go into my dev installation and find this flow, which is just Prefect demo. And I'm going to just kick it off. It may take a minute to do what I want. So when you hit quick run, you can sort of see live what's happening. We see that it's gotten a bunch of data and it has sent the email, and it actually ran really fast. Before we look at the code, I want to just give you an idea of what happens. The code eventually is going to send me an email. Our email servers have been a bit slow, so it may take a minute or two for me to get it. But the code is going to send an email. You can see from the schematic that before it can send the email, it first needs to grab some local data. It needs to run this task. This task actually just fills in the body of the email. It also needs to run a task to get some data from Azure. This particular task gets some Azure data and writes it to a specific location that send email will use to grab and attach. So or attach to the email, that is. And then this Azure data task needs to wait on the credentials before it can actually access that data. So let's look at a bit of code now. Okay, so again, the tasks that I have set up are one, to get the local data that's going to return text that becomes the body of the email, get credentials, which will get some credentials from our Vault server, and then a task to query Azure for a particular file and then write it locally. And finally, once all those have run, we can send the email, which is going to, again, get the data that's locally stored for the body of the text, body that is of the email, as well as attach the file that was written by the Azure task. And one thing that I'll note is that the send email task should wait on get Azure data to complete before it runs, even though that file is not written or is not read in as a parameter to send email. So when we write the flow to define the dependencies among these tasks, we start out our statement this way with flow as flow. We name the flow here, Prefect demo in this case. And then we're just going to start piling in our tasks. We have a task to get our credentials. We use that to specify a few different secrets. And then we run our get local data task as well as our get Azure data task. And then finally, we run the task to send the email. And The nice thing about this particular task, for sake of illustration, is that it shows both of the ways that we can set dependencies between tasks within a flow. So one dependency you can see here, body is a parameter for the send email task, and so Prefect knows that send email needs to wait until body has completed. But we've also set update cloud data as an upstream task, and so that's an explicit way for Prefect, or to say to Prefect that we want this task to wait until upstream tasks has finished. And you probably just heard that I got the email, so it's a little slow, but it worked. So the next thing that I want to do is talk about some of the really nice features that the API exposes. With that in mind, notice that when I define my flow, there were a couple of things that I haven't told you much about. I have this flow defined with a schedule as well as a state handler. So I'll talk about those for just a moment. Schedules are really easy to set up for jobs. There are a lot of ways to set up schedules. Prefect provides a nice variety. I tend to just use cron. So there's a cron clock that you can use, but there are many other ways to set up schedules. You can take your pick. And then state handlers, recall that those are ways to essentially react to the change of state of some task or perhaps a flow. And you can just pass those in as parameters for your task or flow. So I had email handler as a state handler on the entire flow that I showed you. That email handler will send an email to me if the job fails. And this is basically the idea. It's pretty simple to write a state handler. It's not a task, so it doesn't get decorated with @task. So email handler takes an old state and a new state. It takes the object. This could be a much fancier definition than it is. In this case, I don't care what the old state is. I don't even have to use it. All I really care about is whether the new state is failed. And if that's the case, then I'll do something and return the new state. And that's all I need to do to handle the change of state if that is failed. So moving on, there are a lot of really nice features for fine-tuning task settings. You can set timeouts, retries, retry delays, many other things through the tasks. So you can pass those as parameters to task. In the case of my Get Azure Data task, I have all of timeouts, max retries, and retry delays set. Again, just passing those as parameters to the task. Prefect also has a really nice simple API for some nice clean logging. So to set up logging on a task, really all you need to do is create a logger by calling the prefect context. And then you're on your way. Logger.info, and write your code as at will, just include logger to write whatever messages you want to log. And I think I can show you an example of this particular task and show you how the formatting looks. So let me run over here and find that flow really quickly. Let's look at one. Let's see sorry for giving you all headaches here. This was the get local data task. Oh, I'm on the wrong flow. All right, sorry about that. I think it was the original one. It was, I'm silly. There we go. Okay, so get local data is this particular task. And so you can see the logs show up here. So I had a log to read data from the path and then to say found text. And you can see that it's showing up here pretty nicely. All right, one more. So here's the thing that you should never do when you're giving a talk. You should never decide 15 minutes before the talk to throw up a brand new slide before you practiced it. But I did, so this is great. But the reason that I did is that I just had a use case for learning how to use parameters come up about 4 o'clock yesterday. And then I wrote some code to use parameters today. I wrote a flow with them. And I was like, what could go wrong? I'll just show you all this too. So you can add required or non-required parameters with or without defaults really, really easily. All you have to do is add a parameter to your flow definition and then use the results. This is the first time that I've had this come up as a use case because generally for our production jobs, parameters are set via a config file that is handled by Git. However, there was a job that I wanted to write to allow us to move data among Azure containers and storage accounts ad hoc. And so if you're going to do that, you need to, at runtime, set parameters. So this has turned out to be, again, really cool, really seamless. Oops, not quite yet. So the flow that I set up is this one. And so again, this particular flow requires runtime parameters. And so you'll see that I get a really helpful message saying that I can't just hit the quick run button. I have to set some parameters first. And so I can go into run and set them via the JSON that you see here. So again, pretty seamless. All I had to do was add essentially one line of code for each of these parameters. And I had them in the UI, which is pretty cool. All right. So again, that's a lot of features of the API, but there are so many more that you could dive into and go crazy with. That's probably enough for this talk. I do want to take a moment to just show off a bit of the architecture and give some information about our CI/CD integration, and then I'll wrap it up. So the current architecture looks like this. We have a virtual machine in Azure where we have our prod installation of Prefect. Jobs end up on the virtual machine via GitLab. So I have GitLab set up to write them to Azure, or the virtual machine that is. GitLab also registers those jobs with Prefect, and then Prefect takes off and manages whatever happens after that. So that is a lot of things moving data among our cloud resources as well as our local resources. We also have a dev installation that's on a local, a Duke local machine. I didn't include that in the illustration just because it was going to get really messy, but it's the idea. And then finally, the CI/CD integration has been something that's really, really nice for us. The basic idea is that you start with a developer building a flow locally on their own machine. They push it to GitLab. Git then handles with GitLab Runner. Well, Git first builds the job. If it builds successfully, then Git writes the job to our virtual machine and registers the flow with Prefect. Prefect picks it up, and then the user can navigate to the UI, test, read the logs to figure out what went wrong, and then go back to development. And this whole cycle can take minutes. It's really, really clean and nice. And that's about all I wanted to tell you. So thank you all for joining.
Thank you. Thanks, Mary Claire.
And I'm happy to take questions, although, again, I'm a data engineer and not an architect. So if you ask too much about Docker, I'm probably going to get freaked out.
I think you've come to the right audience here. By show of hands, who here identifies with the title data engineer? Not too many takers for that. Okay, at least one. How about data scientist? Awesome. Some are not in either of those camps. So if I wanted, I mean, what would you recommend for someone who just wants a very simple quick start? And I'll preface this by saying that when I say quick start, I mean just to walk through and try out the tool, probably on a local machine. I'll preface that by saying that when I started with Airflow, because we actually kind of started with Airflow together way back in the day.
I remember that, Matt. Those were the good old days.
Those were the good old days. But yeah, I didn't start out the right way in terms of trying out the tool. I chose an overcomplex route because I don't think there was good documentation that said, if you want to try this on a laptop, this is exactly what you should do to keep things extremely simple.
I very much remember the pulling of hair that was happening during that time period.
A lot of hair. Yeah, it hasn't grown back.
So fortunately, if you wanted to just play with Prefect as a single developer, you can go to prefectcloud.io or prefect.cloud, I can't remember, but just Google Prefect Cloud. And the cloud version is available in a limited way to use for single developers. So that's probably the best way to start. If you wanted to get your hands a little dirtier and install it, it's actually pretty easy to install because it's really just Docker containers. So install Docker, install Prefect. You also need Docker Compose, but install all of that and start Prefect. It's pretty straightforward to actually get started.
Nice. Okay, and so generally the recommendation is not to try to install it locally, then just stick with containers through the whole trial.
Well, installing it locally is installing it with containers.
Yeah, that makes sense.
There's no brew install Prefect.
Oh, brew install Prefect, no, that doesn't work.
Is that, Mary Claire, is that how we run it? Is that how we have it running in Azure in containers as well?
Yes, it is. Although, as I mentioned, they're going to be releasing support for Azure ML, and it'll be really cool to see if that is a system that would suit our needs. It's probably more power than we actually need as a team right now, but perhaps one day it would be really useful.
Have you guys looked at what is Azure's Kubernetes service? It's like AKE or something like this. Have you looked at deploying there for more resilience?
It's something that I've thought about, but I haven't gotten I know very little about Kubernetes. I know way less about Kubernetes than I do about Docker, so that feels very intimidating.
That makes sense.
I think I would actually maybe consider messing with Dask before I did Kubernetes, but that might be actually worse.
Yeah,
I don't know.
Yeah, I wonder how hard it would be to spin that up. I'm just remembering the old days again of having Airflow running in containers on a local machine. And then the Docker client would have a memory leak and it would bring down the whole machine. But it sounds like you guys have had okay luck with production on it.
It's been actually really, really seamless. We have had one major issue, and we thought it was a memory leak due to Docker or Prefect or something. Turns out the issue was not with Docker or Prefect. The issue was with our systems folks who decided that an 8 gigabyte a machine with 8 gigs of RAM would be totally fine for some kind of production environment. And it's not. So
in
I had
other
to
words,
do some creative coding to get around that.
Oh, they haven't upgraded you.
Not yet. That's next on my battle list.
It's economical, I guess.
I guess it's economical. Sure, it's fair.
I have a question about the architecture of Prefect. I may have missed this, but as far as orchestrating tasks, is there some kind of messaging system like Airflow has?
I'm not entirely sure. I know that so again, this is this is pushing the limits of my understanding of the system. So what is kicking off jobs is an agent that's running in the background, and the agent talks to the server and queries for jobs that need to be run. It's, in my case, just a single agent. So it's talking to the server about all of the jobs that are available and that need to be running. Beyond, that's about the limit of my knowledge, though, of this.
Yeah, thank you. No problem. I have some other questions, but I don't want to monopolize. So if anyone else has questions. All right, I will monopolize then. So as far as like tasks go, could you have a task that's not like a Python script or Python code? So like if I wanted a task to be run this container and then expect an exit code, for example.
Yeah, there are actually like a lot of really cool things. You can have tasks that run flows. You can have tasks that run shell scripts. You can, and this is the task library that I was referring to. There are a host of tasks that is a host of different types of tasks that run a variety of different types of objects, whether it's, I've used, for example, even just like a shell task to run a shell script. So yeah, there's a lot of different options available.
Okay, thank you. And then this is kind of more of a meta question, but in the beginning, you mentioned that you wanted to, design your workflows and write them in Python. And so you didn't want like a UI-driven system, but then you also listed as a benefit of Prefect their UI. So
yeah,
I guess, are you separating out like the things you like to do in a UI versus
that's
things that
exactly,
you don't want?
yeah, that's exactly what I mean. So to be more explicit about what I meant, I wanted to be able to write code to build a job. I did not want to be forced to drag and drop in a UI to build a job. However, having a nice UI is a really, really nice plus. I don't want to write code to go in and toggle schedules on and off necessarily. If, on Friday at 4 o'clock, something starts breaking, I just want to jump on a UI and hit a button. So that's really the difference. I wanted to be able to control jobs specifically by writing code and then be able to version control those.
Yeah,
Hi,
thank you.
Mary. Can I ask a question?
Go for it.
My question is about what is a good way to manage dependencies between several data flows? Let's say you have data flow that depends on the previous one or some other checks on the data you already calculated. So what is a good way in Prefect to do this?
I am so glad that you asked that question. I happened to run across that yesterday on the Prefect documents, or documentation, that is. So if you would like to have flows that are dependent upon each other, you can create a new flow, sort of like a parent flow, that manages those dependencies. And there are specific tasks in the task library that you can use to kick off flows. And so that's a really nice way to do it. It's like a flow of flows.
But for example, if I have two flows that are, standalone flows that I schedule every day or every week, and then to make a new one flow. So can I just build one flow on top of these two, somehow to wrap them? Or I need to build some library of these tasks and create 3 different flows and just import this task into each flow?
Okay, sorry, I think I see what you're saying. Yeah, in that case, you would probably just want to hand build a third flow, although there may be some functionality that I don't know of that would allow you to do it more seamlessly.
Okay, we need to check this.
Yeah,
Sometimes it's very useful.
Fair. Any other questions? Well, thank you all so much for joining. I very much appreciate it.
Thanks for your talk.
Thank you.
Really great job. I mean, frankly, Joe and I were talking about this on Slack rudely while you were talking, but it's rare to see a talk that does a good job of showing code. That usually kind of goes south. You did a fantastic job of that.
This is why you ask a lady to give a talk.
Touche, fair enough.
100%.
Well, he'll be giving talks every week now, so
That's right.
congratulations.
Exactly.
Awesome. Thanks, Mary Claire. It's been great. And thanks, everybody, for showing up, too. Good turnout. And we'll have this posted online very soon, so stay tuned for that as well. So, yeah, thanks, John.
Thank you.
Thanks,
Thanks.
everybody. So, have a good one. Have a good weekend. Bye.